Please permit me to stand on already existing protocol. My name is Dr. Sobraka Pesimana, and I will be talking briefly about methane, anthropogenic methane emissions and mitigation strategies. Because of time, let me go straight to slide 4. We said methane is emitted from both anthropogenic and natural sources. And thank God for our dear prof that said about 60% of it come from anthropogenic sources and then 40% from natural sources. And you will agree with me that both the anthropogenic and the natural sources, we already have them here in Nigeria. For instance, the natural sources, we talk about the vegetated wetlands, which we have so much. Go to number 4. Sources of methane. The anthropogenic sources of methane come from about 3 major sectors. The fossil fuel, which is the energy sector, and then the agricultural sector, and then the waste management sector. Now, the anthropogenic methane emissions, on a global level, we have about 350 to 390 million tons annually. 350 to 390 million tons annually. That is what human activities produce. Let's go to the next slide. Now, looking at the 3 sectors, the fossil fuel or the energy sector, oil and gas alone gives us about 23%, which is about 78 million tons per year. And then that of the coal section gives us about 41 million tons per year. Now, this is a gas flaring and a shell oil and gas facility in Bonny, Niger Delta. That's to tell you that these things are with us here. The next slide, please. Now, in the agricultural sector gives us 42% of global emission. That's about 147 million tons annually. And we have the enteric fermentation, which comes from livestock rearing, the cattle, the pig, the sheep, goats, and then of course the poultry. That gives us about 30%, and then the manure management 4%, and rice production 10%. So in Nigeria here, we do a lot of cattle rearing. The next slide, please. And then this is paddy rice farm from Ugoja in Cross River State. This is in Nigeria. What we mean by paddy rice farm is that it's rice farming that is done in wetland. Okay? So this happens in Nigeria, and from this we get a lot of methane emission. The next slide, please. The next one is the waste sector. That also gives us about 20% on a global level. That's 43 million tons annually, globally. And then, basically, we have 2 subsectors there. The solid waste management, to talk about the landfills and all that. Then the wastewater. This is me, one of our open dump sites in River State. So we have this, so much of it in Nigeria. And so much of methane is being emitted. The next one. This is a wastewater treatment plant. From wastewater treatment, we also get methane. I'm sure maybe in Abatement State too, people also have wastewater treatment. The next slide, please. Now, methane emission in practice. What we are looking at here is to tell us that in our day-to-day activities, we emit methane. So we did a case study using organic waste and that of cow dung. We went to the dump site, took samples, and then we did the waste character that we separated the waste into organic waste and other metal, textiles, and all that. Now, the organic waste component from our own research came to 47.1%. 47.1%. Now, why I want us to pay attention to this is that research has shown that in developing countries like Nigeria, 50% of our waste stream is organic waste, and that is where the methane comes from. So it's a very serious problem that we have in our hands, and these are the parameters for the both samples, the organic waste samples, and then the cow dung samples. We took 10 kg of it. The next slide. And this is me taking samples, the cow dung from an abattoir in River State, and also the waste dump from the solid municipality with open dump. The next slide. We, in collaboration with River State University, the Department of Agricultural and Environmental Engineering Laboratory in River State University, we partner with them to analyze our samples to see how organic waste and cow dung can produce methane in practice. So this is me, and this is the setup. It's similar to what Dr. Chukwudu just told us. Let's go to the next one. And this is the laboratory setup. You have the panels down there, then the gas comes into this tire tube. Every morning, the lab assistants at the company lab, you see that these bags are filled with biogas. We did this for 60 days. 60 days, and each of the days, they are coming to take sample of the gas that is being produced. The next slide. Now, this is the results of the gases that are produced from day 1 to day 60. For instance, day 1 from the organic waste, we had about 17.9 liters of biogas, and then for the cow dung, we had 1 liter. Let's go to the next slide. So this is a graph of how the gas produced for the 60 days for the cow dung, and then for the organic waste. We took a graph of it. Let's go on to the next one. Now, this is the high point of our research. At the end of the 60 days, we took our samples for gas analysis. And from the analysis, we have the different gases that came out from the biogas, the hydrogen, the methane, carbon monoxide, carbon dioxide, hydrogen sulfide, water, nitrogen, and oxygen. Now, this is what interests us, the methane. From the organic waste, we had 48.96% of that biogas as methane. And then from the cow dung, we had 54.31% of the biogas as methane. How do you understand me? Yeah. So, do we have methane in our organic waste? The answer is yes. In our cow dung, the answer is yes. And these samples are taken from Nigeria. So, in our day-to-day activities, we emit methane. The next slide, please. Now, methane abatement targets. We're talking about methane abatement or methane reduction. Globally, targets have been set. What do we mean by target? It's okay, so and so time, we want to reduce this emission by so and so percentage. Globally, for us to be consistent with the 1.5 degrees centigrade global reduction, the world has agreed that 60% of reduction below the 2020 levels by 2030 and nearly 80% by 2050. Now, what that means is that I told us that annually, globally, we produce about 350 to 390 million tons of methane. So, it is expected that by 2030, that figure should reduce by 60%. In Nigeria, we also have our own target that we want to reduce our methane emission by 45% in 2025, and then by 60 to 30% in 2030. Now, look at this now. Lagos State has a target of cutting their organic waste methane emission by 15 to 20% in 2030, and by 45% in 2035. Lagos State generates about 13,000 metric tons of municipal solid waste on a daily basis, and about half of that waste, emits methane. How do you understand? Now, goes to tell us that we should not leave this matter only to the federal government or to developmental organization. We, at our own level, must know how much methane we are emitting and begin to set target. Because whatever policies, plans, or measures we take, they are all aimed towards meeting these targets. I hope you understand me. The next slide. Strategies for reducing emission. Prof talk about enough of talking, enough of conferences. What do we do to reduce this emission? Now, a combination of technological solutions and behavioral changes is very, very key. In the oil and gas sector, 70% of emissions can be abated using technologies. There are, emission reducing technology that can be applied. Natural gas for power production and then vehicle fuel, that the compressed natural gas can be used to, power our vehicle. That's the gas that will flare. It can be captured and used for fuel. Elimination of gas, flaring of associated gases, adoption and implementation of regulatory standards in a downstream, midstream, and upstream. That's what NESRA does. We need to ensure that there are proper regulatory standards. And in the agri and waste management sector, use of biodigester technology. Thank God the man that spoke before me has told me about that. This thing is real. And if we implement it, it can help us to reduce our emission. Then capturing methane as a source of energy, we have talked about that. This methane that we allow to just go over the place, we can capture it and then use it for cooking, electrical generation, then reduce food waste. Now, the organic waste that causes methane emission, bulk of it is from our food waste. And in developing country, research has shown that we have a lot of food that we waste from our kitchen, from rotting, things and all that. If we have a culture where we can reduce this food waste, it means that we help to reduce methane abatement. Then alternate wetting and drying of rice cultivation. That for those who do rice production, there are methods that they can adopt to reduce emission. Then we should stop open burning of waste. The next slide. Benefit of methane abatement. There are so many benefits. It will help to reduce greenhouse gases and also other air pollutants, provide local source of energy, we talked about it, convert a waste product into revenue source. When we do our biodiversity, the effluent can be used as manure in our agriculture. And Dr. Chidi said that, talked about it. Creates renewable energy that can replace the fossil fuel. Fossil fuel is one of its major sources of methane emission. Then it will create job. Any project that we do that will help to abate methane ends up in creating job, prevents premature death, prevent crop losses, and improve agricultural practices. The next one. Conclusion and policy options. Abating methane emission will be critical to achieving the 1.5-degree warming pathway and avoiding the worst effect of climate change. Our findings in this research will aid in the formulation of appropriate policies and strategies to mitigate methane emission in the immediate or near future. In order to meet Nigeria's target to reduce methane emissions by 45% in 2025 and 60 to 75% by 2030, achieving these reductions will require the following activities. Effective monitoring, measuring, and reporting is very, very important. One of the challenges we have in Nigeria is that we do not have proper records of how much methane we are emitting in the various sectors. And part of this project, we are trying to do what we can. Thank God for the IPCC guidelines that will help us to estimate methane emission in the various sectors. Continuous education and awareness creation. That's one of the reasons why we are all gathered here. There is no environmental initiative that can fly without properly educating the people, especially at the community level, because they are the drivers. If we want to solve environmental problem and we are waiting for government, it will not work. Let us take it, ourselves, take it to the community, but before that, educate them. Everybody is a stakeholder, the government, the politicians, the community people, this civil society organization, religious, for everybody. But not just saying, let's leave it to government, no. So the stakeholders will be engaged, and they will be part of that initiative, implementing methane emission reduction technologies and practices like the biogas technology we talked about, then capacity building. We keep training. The biogas thing we talk about, if you don't train people how to set up the biogas and use it, it will be a difficult thing. So part of what capacity building will achieve is to train them, then research and development. We can't overflow that. We need to keep doing more and more research. That's why the academia is part of the stakeholder. Thank God for our dear profs here. I'm sure we have learned so much from them. And I'm sure if we put all these things in place, we'll be able to meet our targets. Thank you.